Welcome to another procedural texturing tutorial. In this one, we're going to take what we've learned so far and be making this knitted throw. We're focusing on the nodes like normal, but I will give a quick run through of what I did to go from a flat plane to this scene that you see here. The material itself is made up of two parts. There's the section that is creating the actual knitted pattern, and then there is the section that is creating the colors. In previous episodes, we've created a group node that has all of the controls on the front end, but this time we're just leaving this one out as the nodes. But we have access still to things like the scale of our texture, the size of our mask in the background, along with the color. If you're following along and you're not sure where I've got a node from, then have a check down in the description below, as I'll have a list of all the nodes and the shortcuts I use in this material. This is a fun one and I hope you'll enjoy it. Let's get stuck in. We're going to be using Blender 2.82 and Node Wrangler. Make sure that is enabled. In my procedural texturing workspace, I've got a node space and I've got a 3D viewport, which I just want to put in a plane for now to see what it is that we are doing. Now, in all previous tutorials we have used object coordinates, but in this lesson we are going to be using UV coordinates. Using UV coordinates is going to allow you to mark your seams, unwrap, and then you're going to be able to have different angles for your different areas of knitwear. CTRL+H to hide the unused node sockets, and let's have a look at a reference. So what have we got here? We have got lots and lots of threads, and they go alternating angles, and we have rows of them going vertically, horizontally. Each one of these columns all contains threads in the same direction. So we need to think about this as a grid, and you can add a number of things. So we've got our main element, which is this stitch, and then on that we have these threads within. In lesson 2 we looked at making a grid, and we're going to do that exactly the same here. So converter, vector math, change this to scale. This number is going to be the number of stitches that we have in our UV space. If you want to increase this by whole numbers, you can press and hold Control while you drag, and that's going to snap it. So I'm just going to leave that 6, and I'm going to duplicate this scale, and I'm going to change this to fraction. What we've got is now a grid. I need to move every other line up. To do this, I'm going to separate my X and my Y, and then I'm going to rejoin them back together. For us to go from this grid to a zigzag pattern, I'm going to take my X and I'm going to use a function called ping pong at 1. What this does is it goes from 0 to 1, and then it goes back to 0, then it goes to 1, then it goes back to 0. If we add this to our Y, then basically our Y direction is moved. Here we have 0, but at this point we have it being 1, and then 0 again, and then 1, and so on. Now this is going to be our new Y coordinate. But then if we have a look at our fraction node, you can see that we're getting a zigzag pattern. You'll notice when we have a look at our reference here that the steepness of our ups and downs are way steeper than this one. For us to do that, we need to compress horizontally. Go shift, right click and drag, make a reroute. I'm going to copy one of the math nodes and drop it onto there, and I'm going to set this to be a multiply. I'm going to select that reroute, CTRL+X to dissolve it. This multiply, I've found that 1.5 gives us a pretty good approximation. So now what we need is we need to actually put our main elements onto this space. How do we get our ellipses onto here? We've made circles before, and we're going to use the exact same process. So I'm going to add this as a length node. Previously, when we've used object coordinates, our 0, 0 position would have been in the middle here, but because we're using UVs, our position is on the left lower corner. So to move our circles into the middle, I'm going to take a subtract, and on the X and the Y, I'm going to set this to subtract 0.5, and that is going to move all of our circles to the middle. So at the moment we have the sort of fundamental building block of our stitches. We're going to add a color invert, already makes them look a lot better. And then I'm also going to add a color mix RGB, color burn set to black, and when we adjust our factor, you can see that that is affecting where these come together. So if we increase this slightly, you can see that we already have pretty convincing knit pattern. The second part of this is that we want to get our subthreads crossing our strings here. There's a very easy way for us to do this. We're going to take our fraction. This has UV spaces, and we're going to add a texture, wave texture. The normal texture looks like this, 45-degree angles. We're going to take our fraction, drop it in there. Just before that, I'm going to drop in a vector mapping node, and I'm just going to tweak the Z rotation here, -10 or something like that. I'm going to drop detail way down. I'm going to leave wave set to sign, and I'm going to reduce the scale as well. Scale I'm going to put to 1.5. How do we combine this and this? I'm going to use another mix RGB. So I'm going to put my thread pattern, this wave, into the bottom, and I'm going to put my general knitting pattern into the top. I'm going to change this from color burn over to soft light. Now if we have a look at this, you can see that we're adding that thread pattern. You want to have a play with your soft light factor just to see what you think looks good. And leave mine maybe 0.7. Now let's go back to our reference real quick. You can see that there is some variation going on. So here, for example, we have more wide fat threads, and here we also have fairly wide fat threads. However, we've got some taller, thinner ones here, some that may be asymmetrical. You've got all sorts going on. Now if we have a look at ours, if you increase the scale, every single thread is absolutely identical, and we don't really want that. We would like there to be variation. I'm going to add a texture, noise texture. I'm going to plug this from our scale output. I want this variation to scale with our texture, and I'm going to be adding a large noise texture to give us general variation across the surface. If we drop the detail, and I'm going to drop this one down to maybe 0.2. I'm going to add a color, mix RGB. I'm going to take the color, drop it into the bottom, change the mix to linear light, and now you can see that we're getting this variation coming in. And if we have a look at our overall pattern, when we start increasing the factor here, we get a little bit of a warp happening. I'm actually going to add a second noise texture as well. I'm going to go CTRL+SHIFT+D to duplicate with the input. I'm going to add a second linear light as well. Take the color, drop into the second. The first noise is mostly just to give us a sort of deformed surface, as if this fabric is sort of hanging over things and it has different tension on different areas. The second noise we're adding is going to give us different sizes and shapes per thread. So it's important that this one is a little bit bigger. I'm just going to set this one to be 1. I'm also, to this noise texture, I'm going to add detail. And the reason behind this is that you can see that we're starting to get a little bit of a sort of worn edge on there. Set the detail to 3, and we just need to work out how much of a factor to give this to make our variation. 0.15 for mine. This is kind of it for the thread pattern. Now we need to start attacking how we're going to color these threads. I want to put an image on the quilt that we're going to use. I'm going to add a texture, an image texture, and I'm going to open a picture that I downloaded. This picture I've downloaded from Unsplash. I'm using this one. I picked something intentionally with a dark subject and a pale background. If we take our image of a cow here, first of all, I'm going to be using UV coordinates, and then I'm going to add a vector mapping, and you can see it's really squished. I am going to change the X scale, and I'm just going to recenter on the plane. We've got our cow. If I just take this and add it to our knitting pattern, I can take the cow, I can change this to multiply, and I can add the color into the bottom there. If I make that 100%, then you can see that it doesn't really look like much. We want to make the cow look as if it is stitched, and the way for us to do that, rather than using this UV map input, we want to use some form of this. Really simply, we can just take our fraction node here, change it to snap, and change our snap value to be 1. Now you're going to see something happen when I plug this in. We're going to get stripes of value. Now why is this? Set this to extend here. Why are we getting not our cow? Well, this is because our snap values go from 0 to 6, and we want our UV space to go from 0 to 1. So we need to do some adjusting of this space. I'm going to add another vector math, change it from snap to divide, and I'm going to take a combine XYZ, and I'm going to drop that into the bottom here. So I want my Y to equal 6, and I want my X to equal 6. So at this point you can see that it is starting to look a little bit more like something, different colored threads. Rather than this scale being on here, I'm going to add an input value, plug that into there. I'm going to change this value's label to scale. I'm also going to take this value and I'm going to plug it into the X, shift right click, and into the Y. Now as I increase the value here, you can see that our cow appears made of blocks of color. It's a little bit squished though. So the reason that it's being squished is that we have compressed our X scale here. With this set to 1.5, we need to be multiplying the number that we divide by. That sounds a little bit confusing, but I'm going to add a multiply. I'm going to add a value. So this is one that I need to be consistent across both, even if I change it later. So 1.5 into here, 1.5 into here. I'm going to take our number. This is our scale number. I'm going to plug that into this multiply, and I'm going to take this multiply and plug this into our X. So now you can see that our image is properly mapped onto a 1x1 square. Now we've correctly mapped our snap values to create our UV space for the threads. We can use this to do a number of things. For a start, we have our cow, which you can have in any resolution you would like. And if we take this and we multiply with our threads, this now lines up to our threads and it looks quite a lot more like a knitted cow. I want to put a circle behind the cow, but in front of the white background. Just so that we can see what I'm doing, I'm going to add a UV map. I will go back to this snapped one, but just for now, so that we can visualize this, I'm going to be using just an undistorted one. I'm going to append the shapes node that we made in lesson 1. So file, append. In here, I've got my shapes, node tree, shapes, SHIFT+A, group shapes. Now I want the circles, but we don't want them to be at the corner, we want them to be in the middle. So converter, vector math. You could do this with a mapping node, but I think vector math is slightly cheaper. Then I'm going to just drop this down to 0.5 and reduce the size. I'm going to make the fall off much harder. If we have a look at our cow, we can separate it from the background basically by making a mask. SHIFT+A, converter, color ramp. Have a look at this now. It's gone black and white. I can increase our black flag and I can pull down our white flag. flag. And now you can see that we've got something resembling a black and white mask of our cow. So if I was going to use this, I could take a mix RGB, plug that into the factor, and then take my cow option and put this into the first socket. Then you can see that we've got our cow cut out onto whatever coloured background. Rather than this being multiply, I'm just going to set this to mix. Cow is black, so it's using slot 1, which I'm just feeding the cow photo back into. I am going to take another mix node. I'm going to plug the cow into it, and I'm going to add a circle as a mask into our factor. And I'm just going to change this colour to cool blue. I'm going to increase the size, so this is still working just as a mask. So now I want to put my cow back on top. If we use this as the background and the cow masked out as the foreground, we've taken the cow, we've put a circle on top of it, we've cut out the cow, and we've put it back on top. Rather than taking this off the UV map, I'm going to take this off our snapped coordinates. And you can see that this is all working just as it should with the snapping value. You might have seen some jumpers that have a kind of random thread colour thrown in, and it's not on every stitch that's random, it's some number of stitches. I'm going to add a texture, white noise, come from our divide up into here. We now get a random colour per cell. Change this to 40 so that you get the white noise having a seed. If we take this and we give it a colour, and then I'm going to take this white noise texture, I'm going to put it into the hue. The factor is going to define how far away from the original colour we shift. So I'm going to set that to something fairly low, 0.2 is fine. And now I would like to have some way to control where we are putting this. So let's take another mix RGB here. Take a second white noise texture. I'm going to change the seed. I'm going to add a convert map. I'm just going to set this to be less than. Now if I reduce this, you can see that we get the mostly black, and as we increase it, it goes to white. If I set this to be something fairly low, and I plug this into the factor, and I take our hue saturation here and I put this into the bottom socket, then you can see that as we increase it, we get a new amount of our random threads. I would like this to affect our cow, but I don't want it to be these sort of random colors, so I'm going to change it from mix to hue. And what this is doing is it's taking the saturation and the value of the threads, but the degrees around that circle it's inheriting from this output here. Now we have the color of all of our threads, we have the information about the shape and detail of all of our threads. Following this hue, I'm going to add a mix RGB set to multiply. I'm going to put our color information in the first one, and I'm going to add our soft light to the second slot. What this does is it allows us to say whether we have a lot of color or not very much color from those threads. Now the reason that I'm doing it this way around, rather than putting the color on top of the threads, we are putting the threads on top of the color, because when we do our displacement to make this into a 3D texture, then we may not want to have the additional shadowing caused by the color of the threads. Let's turn this into an actual material. First thing we're going to look at is displacement, so that we have some three-dimensionality. Make sure that you are in cycles and your feature set is experimental. Go down to your spanner icon, this is your modifiers tab. We're going to add a subdivision surface. First, this is going to look a bit weird, but we're going to change this to simple. What simple does is it just adds levels of subdivision, whereas the Catmull Clark will add subdivision, but it will also try and smooth sharp corners. We're also going to set this to be adaptive, and adaptive means that when we render it, it basically says divide according to how much space it takes up on the camera. Once you've added your subdivision surface, we can go ahead and add a displacement node, vector, and then displacement. I'm going to take our soft light readout, which is the color of our threads, and I'm going to plug that straight into the height socket of our displacement node. I'm just going to go and add a principal BSDF. At the moment, if I have a look at an angle, you can see it's completely flat still. What we need to do is press N to bring up your side panel, options, settings, and change displacement from bump only to displacement and bump. And now you can see that we have something going on here. I'm going to set my mid-level to be 0, and we also have a slide for scale. You do not need very high scale for this kind of thing. However, if we increase the scale of the texture, you can see that we're still displacing our surface by that same amount, which means that we need to control the scale by our scale here. As the scale increases, the scale of our displacement needs to decrease. Add a converter map. We're going to set this to be divide. We're going to put 1 in the first socket. We're going to plug our scale into the second socket. So as the scale increases, the output of this 1/over node will decrease. 1/4 is smaller than 1/2, so in the same way we can use this like that. Now, if I just mute this soft light, you're going to see that our shapes have a peak, and this is because the length node that we're using falls off linearly. As the distance increases, so does the value. We want it to have more of a curve to it. So if I take this soft light and I'm just going to move it forwards, I'm going to take a color RGB curve, I'm going to drop it on that needle. With this curve, what I can do is I can add a little bit more of a curve to our threads. Because we're using a displacement here, we're getting some natural shadowing in the gaps, and that is why you may not want necessarily to be using all of this factor here. That is why we put the color into the top option. At the moment, what we have is holes that should peek through. We do not have any transparency transparency. So we can have a look at our color burn, and we can say where this is black, make it transparent. I'm going to get another converter, math node, change this from add to greater than. I'm going to set this to be 0. So basically this is saying where it is 0 or less, make it black, anything greater than 0, make it white. I'm just going to feed that into the alpha of our principled node. So now you can see that we have holes going straight through where there should be holes. Our threads are also really, really shiny. I'm going to increase the roughness up quite high, and I'm also going to reduce the specular quite low. And to be honest, that is it for making this into a material. We have a control for our scale here. I'm going to increase this to 30, and you'll get a little bit more of a look at our beautiful cow. I'll increase this a little bit higher, let's go up to 60. So when we zoom in just a little bit, you can see that this is still made up of threads. Each thread has its own color. We can play with the factor for how far out these colored threads want to appear. And we can play with this less than as well, and it'll let you choose how many threads get the variation. We can also change the color of the background as well if you so wish. I'm going to keep mine as a blue color, and you can totally change the size of this as well, and the fall off still works. This video is about nodes, but I'm just going to run through making a quick presentation scene where we have a chair, throw this over the back of it and give it some basic lighting, and I'll do that at super speed so you can kind of get an idea. The first thing I do here is add everything I want for my scene. This is a Nakashima chair asset that I've had knocking around. It's simply textured with a wood roughness map and coloured to flat black. The environment I'm making here is a quick plane. I'm extruding the back edge upwards and beveling that corner with Ctrl B to round it out. I'm using 3-point lighting with large area lamps to give soft lighting and using black body nodes to colour them. Before I do any cloth simulation, I'm creating a simplified shape of this chair. If I use the chair model as the collision object, I'd have loads of issues with the fabric getting stuck on those spindles at the back. So to save time with the simulation, I'm just modelling the rough shape to act as the collision object. The cloth sim I've done as basic as possible. I've set the rough chair to be a collision object and given it a lot of friction, lowered the outer thickness so the fabric sits closer to the mesh. Then for the plane, I've rotated it so it lands on an edge first and folds slightly, and I've made sure that the subdivision level is high, and I've given it cloth physics. This button here exposes presets, and I've just used the denim preset for mine, playing with the settings like collision distance and self collisions. If self collisions is calculating really slowly, then you might be able to reduce your subdivision count and still have good results. I'm using the timeline now to select the frame I like most for my simulation, and then I'm applying the modifiers to essentially bake the geometry to the shape. Next thing I'm adding is a particle system. Set it to hair and tick the advanced box. Reduce length to 0. Under the physics, slightly increase the Brownian value to get those frizzy hairs. Play with the hair shape. The diameter root needs to be way lower. I add interpolated children for mine, and my final settings are 1000 strands and 100 children. I made some quick adjustments to the mesh to make it sit closer to the chair that I'm using. The rough collision model I did wasn't exactly right, so I need to cinch it in a little bit on the back rail. What you can see me doing here is a little test with the input hair info node. And there is a socket called isStrand, which is a mask between hairs and non-hairs. I was testing with a principled hair shader and a mixed shader, using the isStrand data as the factor. I thought it looked good, but in this case I thought it was fine having everything go through our principled BSDF shader instead. I've included this clip though, just in case you wanted to play with the hairs in that way. On the View Layer Properties tab, the third grey one, take the box next to denoising data. Then in the compositor, I'm enabling use nodes at the top and adding a filter denoise node between the render layers and the composite node. Make sure that you connect all three of these inputs from render layers. For my final render, I'm outputting a 2000 by 2000 pixel image, and I've set my render samples to 200. You don't want to go too low or the denoising will smudge your hairs together. Here we go, this is how the final render turned out. Very simple scene, just a smooth background, some nice warm lighting, the chair, and the fabric simulation with its particle system. Let's have a recap of the nodes. We're taking our UV coordinates and we're scaling them to control the number of threads, affecting some variation with these noise and linear lights. What we're then doing is we're separating it so that we can affect the individual streams where we multiply in X and then add a ping pong to the Y, join them back together. This is when we fork. So following this, we have these nodes creating the thread where we take the UV space per cell, shift it, use a length, invert, and color burn. And that's just going to create our threads really quick using a wave texture. And the soft light, we can create the subfibers to add some detail. On the other stream, we have the snap. We have some maths to remap us to the 0 to 1 range. This needs to be responsive to the scale and the X compression. And then we can push these coordinates out through an image, any sort of procedural shape, or a white noise texture. In this case, we are using a color ramp to mask out our cow so that we can composite the shape behind it. Then adding some random threads, and we are multiplying to add some of the shading back. Drop this into your principled BSDF using a greater than for an alpha mask here. We're controlling the scale of our displacement inversely to the scale of our texture, and this is what is giving us these nice knitted shapes. You can go a lot further than we have here, but hopefully this has given you a taste of what's possible. I fully encourage you to play with these techniques and look at what different nodes are doing and how you can change and improve this. I do try to go quite quickly, so if you're wondering where a node is or some shortcut I've mentioned, check in the description down below and I'll have a list for you. There's also going to be a link to a screenshot of my final node tree, so if you want to have a closer look at anything, then there's a link to that. I'm also going to have a link to the cow image that I use from Unsplash. If you do make anything and share it online, please do tag me. I love seeing your creativity. But that about wraps this one up, so thanks for tuning in. Hope you've enjoyed it, and I'll catch you in the next one.